Hey math lovers, let's go over the quiz number 4. The line y equals 8x minus 4 intersects the parabola y equals x squared plus 2x plus 5 at exactly 1 point. Ooh, this is a big clue. What are the coordinates of the point of intersection? Alright, so basically when you have multiple equations in the same coordinate system, we like to call these a systems problem. And if you notice something about the green and the blue equation, they're both set equal to y. So we're going to do a substitution. Every time I see y, I'm going to write 8x minus 4. I see a y here, and instead of writing y, I'm going to write 8x minus 4. This is a way of solving a system here. And we do that by substitution method. So what did we do first? We did a substitution. Okay, now I'm going to set equal to 0. Let's go ahead and do that. I like to draw a nice straight line here. So we have, I'm going to move the 8x and the 4 to the other side. Line them up with like terms here. And 8 minus 8 is 0. Negative 4 plus 4 is 0, so that side is equal to 0, which I want. I have x squared. Positive 2 and negative 8 is minus 6x plus 9 here. Okay, what we're going to do here is we're going to use the discriminant. Now, it already told us the answer, but I want to double check why. It says up there, it tells us it has 1 point of intersection, so let's prove that. You're going to use the formula b squared minus 4ac. This comes from the underneath the square root of the quadratic formula. And so I'm just looking over here to my left here, and remember a, b, and c. There is nothing in front of x squared, that is a 1. B is negative 6, c is 9. So I'm going to put that in here. So let's go ahead and do that. Negative 6 squared. Remember, your substitution is always put into parentheses. Your a value is 1, and my c value is 9. Let's go ahead and simplify that. Negative 6 squared is negative 6 times negative 6, which is positive 36. And negative 4 times 1 is negative 4, and negative 4 times 9 is negative 36. 36 minus 36 is 0. Now, you're always comparing this to a 0. And I put a box here so that you can put an inequality. And you can put in greater than, less than, or equals to. Well, when it's equals to, you have one solution, which is verified to us. So now, let's do our next step. Let's go ahead and solve for x. What are the ways of solving for x here? Well, it's a power of 2, so you're going to have to use quadratic formula, factoring, graphing, and I'm going to go ahead and try to solve this by factoring. So I have my a times c is 9, and my b value, which is negative 6, and two numbers that multiply to be 9, but that add to be negative 6 are negative 3 and negative 3. So we have 0 equals x minus 3 and x minus 3. So now I'm going to keep solving for x, but right here, this method I'm doing next is called the, we called it, well, don't want that. Zero product row. What does that mean? Set equal to 0. Just set each of these equal to 0. Set it equal to 0. That's what we're doing. Let's go ahead and solve. So you have x equals 3 and x equals 3. They call that a double root. And lastly, we're going to now solve for y. Solve for y. How do you do that? We're going to take our x equals 3 and we're going to have two equations here that are set equal to y. And you get to pick one of these. And I think it's actually easiest to pick the one that has less stuff going on. So I think y equals x minus 4 is the easiest one. So let's write that. Y equals 8x minus 4. And basically, anytime I see x, we can write 3. I see an x, I'm going to write 3. Remember, it's by multiplication. So we have y equals 24 minus 4, y equals 20. Okay, that means my intersection is going to be 3 comma 20, right? Well, 3 comma 20, right? Boom, boom. Okay, so your answer is going to be D. Now, just to make sure you understand why, if you graph our coordinate plane, and in green you have 8x minus 4. So you go up 8, I don't know, that's 4, so that's a distance of 8, and you run 1. And then my equation looks something like this, okay? And then the quadratic is x squared plus 2x plus 5, and that is not factorable, which tells us that it intersects our graph at 5. And all I need to know is that our point of intersection is 320. Okay, let's see. I don't know, 3, let's just say something way up here, 20. What does that mean for my graph? I don't know, maybe something like, I don't know, something like that, right? And the green one goes, and you can just erase, got an eraser, look, boom. And that is 320. Okay. Use a graphing calculator. You want me to use one? Let's use one. 2x squared plus x squared plus 2x plus 5. And then 8x minus 4. Let's graph that. Ignore the red dots. That was my stats lesson. Let me see if I can turn that off. Boom, 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 boom. Okay, there you go. And we said 3 comma 20. And boom. That should be our point of intersection, right? If I keep zooming in, in calculus, this is actually called a point of tangent. The red is the tangent line. Okay. That was question number 1. Question number 2, given the function which is represented in this table. Well, I like x's and y's. So you could just change this table, not against the laws of math. We have x and we have a y. So we have -2, -1, 0, 1, 2, 3, 4, 5. And then we have 21, 11, 5, 3, 5, 11, 21, 35. And of course on this side you have plus 1s, yes? We want plus 1s, okay? It's just to know that it's a function. But over here, let's see what we got. Can I multiply? No. I think we can, I think we're going to subtract 10. Subtract 6, subtract 2. Okay, I'm going to add 2. 3 plus 2 equals 5. 5 plus 6, 10, and that would be 14. Is this a first common difference? Is this linear? The answer is no, it is not linear because we do not have a first common difference. All those numbers in blue are not the same number. So let's go ahead and try now our second common difference. Our second common difference would tell us if it is quadratic. So let's figure this out. I got plus 4, -2, plus 4 gives you 2. 2 plus 4 gives you 6. 6 plus 4 gives you 10, and 10 plus 4 gives you 14. So do we have quadratic? The answer is yes, it is quadratic. Why? Because we have a second common difference. So all the answers already have a power of 2. Okay, this did not help us. Okay, so what is our formula for quadratics? Our formula for quadratics is y equals, let's do that in a different color. Let's do green. We haven't used green. Y equals ax squared plus bx plus c. And let me highlight some things that we're going to use. The a value is our common difference, which is 4. Let's write that. 4. The c value comes from the y-intercept. The y-intercept is 0, 5. So we're just going to write a 5 here. The c value is the y-intercept. The y-intercept is 0, 5. Okay, so this is what I have so far. The a value came from the second common difference. The c value came from the y-intercept, which was 0, 5, okay? All right, let's use red. The x and the y can come from any order pair from our table of values. And the easiest number to pick is one that has a 0 in it. And we already have that. So let's use that order pair again. So my y value is a 5. And my x value, okay, pay attention now. The x value actually appears twice. So we're actually going to write that one 0 squared, and that would be a 0. And why did we do all that? So that we can solve for this b value. Let's put it in a different color. Okay, so we're just basically going to solve for, you know what, I can't pick 0, 5. I can't pick 0, 5 because 0 times b is 0, and then you're not solving for anything. So let's pick a different one. Pick anything other than the 0. let's pick 1, 3. That's an easy number to work with, right? X value is going to be 1, and the y value is going to be 3. Y value is 3, and the x value is 1. Okay, let's solve for b now. This gives me, remember, we're using PEMDAS sort of operation, so that would be exponents first squared. 1 squared is 1, 4 times 1 is 4. B times 1 is just b, or 1b, and you have plus 5. You're going to combine like terms on the one side of the equal sign. So this would be 9. 3 equals b plus 9, right? I just added the 4 plus 5. They're on the same side, use the same math operation. And then if I subtract 9 from both sides, I'm going to get negative 6 equals b. This is good. So let's review what we've got so far. Let's see if I can highlight this in a color we have not used, like purple. I have a equals 4 from the first common difference. I have the c value from the y-intercept, and I have the b value, which I just used to solve. So my new equation, let's just put it all together now. C value is 5, a value is 4, b value is negative 6. Okay, let us hope that 4x squared minus, oh, I know I did wrong. The common difference, the a value is the common difference divided by 2. The a value is the common difference divided by 2. So if our common difference was 4, then the a value is 2. So let's I made a mistake. Let's do that again. So let's just go back. A value is 2. What does that change? Just this value right here. 1 squared is 1. 1 times 2 is 2. 2 plus 5 is 7. And if I subtract 7 from both sides, then this equals, b equals a negative 4. So a values should have been 2 and negative 4. Okay. Do we have any of those over there? The answer is no. Okay, what can we do here? We're going to have to do something. We're going to have to complete the square. All right, to complete the square, I like to first factor out the a value of just the first part. So you have x squared minus 2x, and then I like to write the plus 5 way out there with this kind of like big space right there. I'll put it yellow and a red. Okay, to complete the square, I'm going to have to take, we're focusing kind of inside right here, right? So if I use that as my b value, completing the square is b over 2 squared. So my b value inside there in green is negative 2. And negative 2 divided by 2 is negative 1. And negative 1 squared is 1. Okay, so I'm going to write this positive 1 here. Okay, in order to complete the square, let me show you this in-between step. If we had distributed each of these terms, you would get 2x squared minus 4x plus 2. But you've changed the equation because you have that plus 5 over here, right? So to make the equation balanced is if I take this value and write negative 2. Because 2 minus 2 equals 0. And if that's gone, then I'm left with there and what's in white, 2x squared minus 4x plus 5, which is my original equation. So this one's tricky, but basically, although to complete the square, you're writing a plus 1. To make the equation balance, you have a minus 2. Again, why? Distribute, you'll get the original, and you have to make the yellows there in between here equal to 0. Okay, wasn't so bad. Let's do purple. Magenta, what color is that? Y equals 2, and then there in green, or what we just put in there now, you realize that if you factor it, you're factoring this right here, two values, a times c is 1, negative 2, and you realize it's a negative 1, negative 1. Out here, negative 2 plus 5 equals a plus 3. Put those together, you have x minus 1 squared plus 3. So we actually basically went from standard form to now vertex form. Okay, let's see if that is now one of my answers. And 2 times x minus 1 squared plus 3. There it is. There's my answer. The answer is C. All right, question number 3. Miss Cohen's garden had 50 weeds when she began spraying her garden with pesticides. Okay, people who like the planet do not like pesticides. These are basically chemical plant killers, or weed killers in this case. Okay, you spray it, stuff's gonna die. Every day she sprayed pesticide. There were half as many weeds as the day before. So I love to make charts, don't you? Super organized. Number of those pesky weeds in my front yard. Okay, so in the beginning there were 50, but I call that day 0, right? It was a problem. Then you go out and buy the pesticides, and the next day it tells us there is half as many. So what's half of 50? It's 25. Okay, then what's going to happen on the second day? There's going to be half of 25. So think of half of $25. It's $12.50. And you get the idea. Half of that is going to be $6.25. So which equation do we have here? Okay, let's break these down. This one is linear. How do I know that? Because the x and the y's are to the first power, okay? B is exponential. Are you guys using your foldables here? It's an exponential because the base of the exponent is a number, and the exponent is a variable. So this one's also exponential and linear. Okay, so let's see if we can figure out from our table of values here. So am I adding? Well, obviously you are not subtracting 25. Do you see this? Because 25 minus 25 would equal 0, so that is wrong. Okay, can I multiply by 2? Well, if I multiply by 2, I'll get 100. But you can do something like this. You can multiply by 1/2. Multiply by 1/2. Why is that the case? Because if you do 50 times 1/2, To make 50 a fraction, put it over 1. So when you multiply fractions, you just go across. And the factors of 50 are 25 times 2. And realize the 2's cancel out and you're left with 25. So from 50 to 25, there it is. You are just multiplying by 1/2. Okay. Another way of figuring out the common ratio, I'm not sure if I put that in your foldable, common ratio. Let's just say this is called, I don't know, A1, A2. You take the A2 divided by the A1, and you essentially get what we had, 25 over 50, and that's 25 times 1, 25 times 2, and 25's cancel, and you're left with a common ratio of 1/2. Okay? So, it is not linear. Nope. If I know it's exponential, then our formula is y equals ab to the x power. And remember, the b value is your common ratio in red down here. So that was 1/2, or this mark. So the b value is 1/2. The a value is the y-intercept, which is 50. So y equals 50 1/2 to the x power. Okay, pay attention. Choice B is a common mistake for students because they think 1/2 and 2 are the same exact thing. Remember, 1/2 is the same thing as 2 divided by 1. And 2 goes in there, 2 goes into 10, 5. So 0.5 is another way of writing that. Just think of money, right? $1 divided by 2 people, that's 50 cents each. So that would be choice C. C is the correct answer. Hope that was helpful for you guys. See ya.